Okay, so let's start, guys. Today is the day 16th of our doing late code daily series until I get a job. So today is the day 16th, and today we are here with the DP 1D DP series. Okay, so basically, what I know about dynamic programming is basically dividing the bigger problems into smaller subparts and then finding solution for those smaller subparts, because finding smaller for smaller parts is easy than finding a solution for the whole part. And after we find the solution for them, we just merge them and find the final solution. So we'll see like how we can implement this in practicality. So first question is this: climbing stairs. You are climbing a staircase. It takes n step to reach the top. Fine. Each time you reach, either climb one or two steps. In how many distinct ways can you climb to the top? Okay. So we are climbing a staircase. Okay. And what happens in this staircase is that, let's say this is the top, and if we are starting from here, we are given that at one time we can either take one step or we can take two step. That will be counted as uh, one step. Okay, we have to reach here. How many what we need to find is how many distinct ways can we climb to the top. See, let's say we from here we have to reach here. So for reaching here, how many ways are there? Either we can climb one stair, means one stair at a time, or we can just climb directly two stairs, because we have that option. So these are the two possible cases, so it's ways two. Now we have to go here at the top. Let's take a smaller example, and let's say we have three steps. Now in the case of three steps, either we can go here, 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 one way, here and directly here, two ways, and here and one. Three cases are there in case of three stairs. Okay, so how we can like break this problem into smaller part and then merge those smaller part to find the final solution. See, before three, let's calculate this. Let's take the smaller cases, which are one and two. Okay, so for one, there is just one step. For two, okay, so for two, either we can go from here or we can go from here. Two steps we have. Okay, so in case of three, we know that three is what? Three is basically consisting of one and two stairs. Okay, so if we reach here, if we want to reach here, we can either reach here or here, because when we are here, we can just take one step. Okay, and if we are here, we can take also one step. So if we are at any of these positions, we can just go to the top directly. You got it, right? You got it. So how do I do this is that this is three is the basically solution of what is the solution for climbing up two stairs, and what is the solution for climbing up one stair. After that, it's just one step. Correct. So how many ways can we climb up to here? Plus how many ways can we climb up to here? After this, we just have to add those two ways, and that's our final answer. So how many possible ways are there that we reach here? That's how many steps? One and two. So for two steps, answer is two, and for one step, answer is one. Okay, so total number of steps for reaching up to the top of staircase with n is equal to 3 is 3. Let's now talk about 4. In case of 4, what we need to do is either we need to reach here or we need to reach here. After that, it's just one step. Okay. Okay, because we can climb two stairs at once. That's a given condition, or we can climb one. So that's basically we have to reach the top of three stairs, and we have to reach the top of 2 stairs. So what was the answer for 2? Answer for 2 was 2 and 3 was 3. So answer for 4 is 5. Okay, and we can also visualize this like one way is 1 plus 1 plus 1 plus 1. We take one stair at a time. Second case is 1 plus 2 plus 1. Third case is 2 plus 1 plus 1. Fourth case is 1 plus 1 plus 2. And last case is 2 plus 2. Right? This is how we can do it. So these are the 5 cases we have. So this is how we do it. That the answer, let's take the array dp, because that's what in mostly practices we do. The dp answer for I is dp of any number of stairs I is just dp I minus 1, just one step lower than it, plus dp I minus 2. Because we can also like visualize this thing, that if we are at I minus 1, we can just go to one step and we are done. For I minus 2, we can just go two step at once and we are at the final destination. So that's how we do this. Let's start doing this in code. Okay, so how are we going to do this is that if n is equal to 0, we will just return 0, but n not will 0, so we can remove this condition. So if n is equal to 1, return 1. If n is equal to 2, return 2, because there are two ways, 1 and 1 and directly 2. Okay, so this is the thing. Now let's take an so we can do this like if n is less or equal to 2, return n, correct? So now let's make a vector that's size n plus 1. So what we can do is dp 0, in 0 steps the answer is 0, in 1 step the answer is 1, and in 2 steps the answer is 2. Let's find out for the other parts. Like for I is equal to 3 to I less or less than n, I less than n, I plus plus. What we will be doing is simple less or equal to n, let's say. Okay, because we have taken the vector size as n plus 1. So dp I will be simply equal to dp I minus 1, one step at a time, and dp I minus 2, two step at a time. So how you can see here how we broke down the bigger problem into smaller one, that we are just 1 or 2 step behind the top. How many ways are there that we reach the top? It has, if they are just the sum of the ways that we reach at just one downstairs from the top and two downstairs from the top. After that there's just nothing, we have to just add those two ways. Okay, there's a simple way to understand it. There can be bunch of more ways to understand this question, and we have to give the answer for what will be the answer for n steps. dp n will be the answer for this. So that's how we approach this. Okay, variable length, what's the problem here? Okay, let's take the vector then. Yeah, I guess we cannot take a variable length array here. Vector and no problem, we will take a vector, bro. That will be dp, that will be size n plus 1. Fine, that will work. And I, and yeah, that will work. Next question is min cost climbing stairs. You are given an array integer cost where cost I is the cost of ith step on the staircase. Once you pay the cost, you can either climb 1 or 2 steps. Okay, yeah, it's fine. So you can either step one or two stairs. You can either start from the zero index or the first index. It is the minimum cost to reach the top of the floor. So here the question is same. We just have to pay some amount to climb those stairs. Okay. So if we consider this, that there are three steps and the cost of these three steps are 10, 15 and 20. So how do we do that? We can either start at 10 or we can either start at 15, because we can either start at index 0 or 1. Okay. So if we start at 10, we can either go to 15 and then we will reach the destination. We will take two steps and we will skip the 20th. Okay. Or the other case is we are at 10, we will take the two step 20 and we will reach the top then. So in both the cases, what will be the cost? In the first case, the cost will be 10 plus 15, 25. In the second case, the cost will be 10 plus 20, 30. But what if we start at 15 and take this two step and directly reach the destination? The cost is only 15, right? But in this case, where do we have to start? From 100 or from 1? Obviously, we will start from whichever is the lower cost. We can just apply the greedy here. Okay. At each step, we have to lower the cost. So if we start at 1, we can skip this 100 and we will go to next 1. After that, we can just go to next 1 here. Okay. If we will start at 0, we will go to 2, we will go to 4, then we will go to 6, then we will go to 7, because 8 it's a 100 and 7 it's a 1. So we will go to 1 and then we will go to 1. Right? Go to index 7, index 9 and then reach the top. So what's the ways here is that if n is equal to 1, we just have to return whatever the value of cost 0 is, because there is only one element in this. If n is equal to 2, and is, let's say, cost dot size, and n is equal to cost dot size means the number of stairs. Okay, if n is 2, there are two steps, we have to take any one of them. So whom will we take? We will take whatever is the minimum of the two. So we will just return cost 0 and cost 1. Now let's try to find out for the answer for in the case of 3. Okay, in the case of 3, if the prices are A, B and C, okay, we have to start either from here or either from here. So from wherever we start, doesn't matter. We just have to look how we can reach C here, or we can reach here. Okay, how we can do that? See, we can do that in the same way, like just think about the previous question. What we were doing, we have to reach either here or we have to reach either here. Any one of them will work. So what is the cost for reaching C? What is the cost for reaching C? And what is the cost for reaching B? Minimum of those two plus their own cost will give us the answer. So how many ways we can reach B? We have the DP as the solutions and cost as the costs of particular stairs. Okay, so cost of this 3 will be equal to see, either we reach here or we reach here, correct? So what we can do here is that for reaching here, what we need to do, cost of this stair, cost of I minus 1 plus min of dp I minus 1 or I minus 2. We will understand this. How is this working? See, here let's say dp0 will be what? dp0 will be 0 and dp1 will be, in case of one stair, the cost is c0, and in case of dp2 In case of two stairs, the solution will be min of, let's just say C1 it is. Okay. Uh, yeah. Okay, bro. Okay, I don't know. I just remove the today's solutions. Okay. Very fucked up actually. No worries. We were just writing down something that if we have one stair, the cost will be cost 0. If we have two stair, dp2 will be cost 1. So let's just write down in this code so that we can know it what we are doing. So let's make a vector int n plus 1. Okay, if we have the vector of n plus 1, then 0 to n, but we have to reach n plus 1. Okay, we have to reach the fourth stair, top of the floor. Okay, 3 steps are there. We have to reach at after the 20, whatever is after the 20 we have to reach here. So we will take it n plus 2. Okay, and now dp0 is 0 and dp1 is cost 0 and dp2 is cost 1. See, don't worry about that thing that if what if cost 0 is less. It should be minimum of cost 0 and cost 1, right? If this is n is equal to 2, the answer will be returned here, and this will be taken care of for the future of the solution. How will this be taken care of is that we have to find the answer for int I is equal to 3 and further, right? I to 3 less or equal to ni plus plus. Okay, what we will be doing is that, see, it will be different in the last stair and the rest of the stairs. Okay, if we are at any of the mediator stairs, means if n is equal to, just let's say there are some number of stairs, let's consider the answer for this. For one stair it just cost 0, for two stair it just cost 1, let's just say it just cost 1. Now for this stair, what the answer will be is, see, the cost of this stair plus whatever is the minimum of them, means, it means that, let's say if we reach here, then we reach here, and if we reach here, then we reach here, then the solution will be, let's say this is a, it is b, it is c. So in one case the answer will be a plus c, in one case the answer will be b plus c, correct, for reaching c. So the final answer will be c is same, but whatever will be a minimum of a and b, that we will take the answer, right? So c plus min of a and b, correct, this will be the answer. So that's how it works. But what if we are just about to reach to the top? See, we have to reach here, not here. Okay, let's say this is has a cost of d and this is has a cost of e. So when we are here, when we have reached here at c, okay, we have the solution for c. Now how we can reach d? D will be like either d plus b, d plus min of cost used to reach c or cost used to reach b. Okay, that will be dp of c or dp of b. That will be the solution. Okay, but when we have to reach a, e. Okay, when the next step is e, the final step. See, if we are at the final step, the process won't be same as this. Why it won't be same as this has a reason, which is that now if we are here, we can directly go from here to destination and we do not have to pay anything, or we have to go from here to here, and we have to pay this, right? If we land on this step, then we have to pay this. If we can bypass this step, then we don't have to pay this. We don't have this opportunity in rest of the cases, right? So if we are last step, vi will be what? Vi will be cost of c, cost of reaching c, plus cost of reaching e. Cost of reaching c plus cost of e, that's the final state. After e we can go anywhere. And if we are at d, we just have to cost of reaching d, because after if we have reached d, we can just directly bypass the e and go to the destination. But if we are at c, then we have to pay the cost of e, then we have to go to destination, right? So these are the two cases. That if we are at final stair, see, if we are at final stair, then dp of I will be what? Minimum of dp of I minus 2 plus current cost, cost of I, actually I minus 1, because this is a n sized array and we are going to n plus 1th index. So if I will be n, and cost n doesn't exist, cost n minus 1 is there, so cost I minus 1 or dp I minus 1, just the previous tier. And in all other cases the answer will be dpi is equal to cost of the current stair plus min of dpi minus 1 or dpi minus 2. Yeah, yeah, this must do the thing, and we have to reach where? We have to reach correct. Yeah, this worked. So next question is the house robber, and let's see the video. Yeah, it's doing fine. So for the house robber, we have you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed, and the only constraint stopping you from robbing each of them is that adjacent houses have security system connected. So it will automatically contact the police if the two adjacent houses were broken into the same night. So given an integer array nums representing the amount of money in each house, return the maximum amount of you can rob tonight without alerting the police. So see, we are given the list of houses, and we cannot take any. We have to find the sum, and we for maximum sum, and we cannot take two adjacent numbers at once. We cannot rob two adjacent houses at once. Okay, so what we can do is, let's start from the smaller cases again. Like if n is 1, n is the nums dot size. Okay, n is nums dot size. So let's take smaller solutions first. That's what dp is. If we have smaller solution, we can take, if n is 1, we just have to return n 0. That is, there's only one house, so we will drop it. If n is 2, if n is 2, there are two houses. We cannot rob both of them because they are adjacent. We will just rob whoever have the maximum amount of money. So nums 0 or nums 1, correct? Whoever maximum, we will rob it. Now in all other cases, let's just do this, and let's try to find, like dp0 is 0. Okay, so dp1 will be, if there is one house, it will be just max of nums 0 and nums1, correct? So for all other cases, for int I is equal to 2 I less or equal to ni plus less than n, actually we are taking dp n only.
गाजर आलू
Okay, so we will take less than n because there is an n size dp only. So for this, what we will do is that we are not gonna rob two adjacent houses. So what we can do here in this case is that let's take these are the houses, this, 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 this. How we can divide it into sub problems and we can solve it. See, at any point, let's take there are number of houses in this direction and there are number of houses in this direction, and we are starting from this side. When we reach here, okay, what are the choices we have? Sorry, when we reach, not at this point, but when we reach here at this house, what are the choices we have? If we have robbed this one, then we need to skip this house and go up there. And if we haven't robbed this house, then we can consider robbing this house, correct? So what are the solutions we have if this is I? So dp up to this house, our profit, what will be our profit or what will be our robbing amount that we have to calculate is if we have robbed this one or we haven't robbed this one. So it will be max of, we have two choices and we have to find the maximum choice out of them. First choice is we have just robbed the last house, so the robbing amount up to the last house. Or the second choice is we have robbed this house and haven't robbed this house. Okay, then in that case, robbing amount of dbi minus 2th house up to here, how much I have robbed, plus the amount of money the current house have, means nums I, correct? This is the solution. Oh, and we can see that simple that if we at 0 dp0 is just nums0, dp1 is nums1 or nums2, nums0 and nums1 out of the maximum. So dp2 will be what? We are on the second house. Let's say there are three houses only and we are on this house. What will be the maximum we can take? Either we take this and this, or we can just take this. So max of dpi minus 1 yani this, or dpi minus 2 this plus the money we have in this house. Okay, so this is how we need to go, and it's a simple thing, right? That dpi is equal to dp max of two choices we have, right? dpi minus 1, either if dpi minus 1 is robbed, I minus 1 just last house is robbed, we cannot rob the current house. And if the last second house is robbed, then we can rob the current house, that is nums I, correct? And we will just return dpn minus 1 and that's all. Now what happened here? It was giving 3 and output should be 4. Okay, dp0 is not 0 actually. dp0 is, see, we can take multiple cases here. If we are taking dp0 as 0, that 0 house we have 0 thing, then we have to take this array as nums n plus 1, and we will take dpc1 as nums 0. Okay, and we have to take equal to n, and we will return n, and this will be dp2, and we will be starting from 3. Okay, both of these things can work. We just have to consider that if we are considering 0 houses, because nums dot length will always be okay. Line 12 is something 3 nums I plus 1 it will be there. Nums I minus 1 actually. Nums I minus 1. Okay. So here we that's fine. That's fine. That's fine. Because at last index it will be n, so it must be I minus 1. Okay. So it's given that there will be minimum one houses. So that's why I was not taking this case. But even if we take, doesn't matter. Our code will still work. We just have to modify the size of the array. Okay. So the next question is house robber 2. So in this question, house robber 2. Okay. So in house robber 2, you are a professional robber again. Okay. Arranged in a circle. All the houses at this place are arranged in a circle. Now this time what changed is the houses are not in a line now. The houses are in a circle now. So what difference does it make? What difference does it make from this kind of pattern to this kind of pattern is that the first and last house are also connected. They are also adjacent. Rest of the things are same, but the first and last house are also connected. So we have two cases here. See, the question is just as same as the last one, but there is a little difference, which is that from the first and last house, earlier we had a choice that we can rob both of them, but now we have a choice that either we rob this house or we rob this house. Rest of it is exactly the same. Okay, so how can we approach this now? Is just wait a second. How much time have we took? 31 minutes. Fine. So this is the last question, and we can do this. Let's try to do it before 40 minutes. 8 minutes we have. So yeah, this is the condition that we have to we can either rob the first house or we can either rob the last house, and rest of the conditions will be same as the house robber. So we will just write it out. We will try to copy these conditions. It will be n plus 2 now. N plus 2 now. So, sorry, n minus 1 now actually. See why it will be n minus 1 now, and we are taking only if there are three houses. See, if there are three houses, we can also take this case. Thus, we just have to yeah, we just have to return what the max of any of the houses, max of num 0, because all three are adjacent to each other, right? Num 0 or nums 1 or nums 2, correct? Yeah. So see, we can take the two cases, and whatever case has the maximum answer, we can go with it. What are the two cases is that one case is when we skip the first. Let's say this is 1, 2, and 3 and 4. First case is we just don't consider this house. We will not rob it. Then we have just these three houses. And the second case is we don't consider this house, then we have these three cases, and whichever case have maximum answer we will take that. Obviously we have to skip one, and if we skip this fourth, then we have just a straight line of houses, and the house robber question exactly nothing is changed, right? So we will take dpn in both the cases, not n plus 1, because this time we are missing one house. Only two houses we are considering, unlike the last time where we are considering n plus 1. Okay, so dp0 will be that, let's say this is dp1. So dp1 of 0 will be again 0, and let's copy this next two conditions also. We are not considering the last house. Okay, this time the last house. So dp1 and dp1. Fine. Now the next thing will be we will start the loop from I is equal to 3 to I is less than n now. One house less. And I plus plus, and dp of I will be, if we max of, if we take the just the last house, we won't take anything, dp1 of I minus 1, And if the last house not last second is robbed, dp1 I minus 2, then we will just add the current house's sum into it. Correct? Yeah, that's it. And in the second case, dp1, and just copy this thing and paste it here. Let's take the second dp now, where we will miss the first house. So dp0 will be 0, dp1 will be nums 1. We are missing the nums 0 now. Okay, and dp rest of the cases will be handled here. Don't think that if one house is there, how it will even reach to nums 1, nums 0 it should be there, that will be returned here, don't worry about that. Okay, so in the case of 2, nums 1 and 2 will be considered. Okay, now we'll go to 3, 2 less than n obviously, but this time we will take 1 plus here, right? If we are at third house, we will consider the fourth, because we are not considering the zeroth house. We are going 1 plus this time. Unlike this, we consider the missing the last house, and here we are considering missing the first house. Okay, so it will be 2, 2, 2, and space of 2, 2, and 2. Now whichever house has, whichever case has the maximum answer, we'll just return it. So we'll just return max of dp1 n minus 1. Why n minus 1? Because the size of vector is n, then the last index is obviously n minus 1, because we are considering 0 as one of the index. Okay, so dp2 n minus 1, and that should give us the answer. Why is this dp2, dp2, which case are we missing here? And okay, n minus 1 should be there. Yeah, n minus 1 should be there. But in this case, it should be n plus 1 then. Correct. No, it should be dpn. It should work. Actually, it should be this. No, no, no. Oh, that will be also wrong. Nums 1 and 2. So it will be starting at 3. It will be starting at 3. And less than just n. 3 to n plus 1 it will take, so it should be n minus 1. Last index will be n minus 1. Okay, so for the n minus 1th index, it will be what? N minus 1 plus 1, n will be there. So let's take it as I. It should work, right? I guess it should, because putting here I meant something, but we are also putting I here. Those will be the same thing. Answer is 4, it's returning 3. So in this case, it is doing 1 and 3, right? Okay, so let's take that case then. Let's take n minus 1 houses. Actually, we are given n houses, we are not considering the last house in the first case, then there will be n minus 1 houses, and let's remove it. And And we will go according to this only. Yeah, we can go with this and minus 1, and we can start with 2. Yeah, same we can do here, that n minus 1 houses are there, and dp0 will be just the first house, and dp1 will be, this is the first into maximum of these two, and 2 will be this, and this will be go to n minus 1 obviously, and it will be I plus 1, and we'll return I minus 2 to n minus 2. Yeah, this should work, because that way we were confusing something. I don't know what we were confusing, I'm not sure about that, but this is the clear way that we are taking just n minus 1 houses instead of n which we are given. We are missing one house, last one in this case, first house in this case. If we miss the last house in this case, we'll start from the first house, we'll take it as dp0, dp1 will also consider this, and then we can go to the end of it. The second time we are missing the first house, the dp0 will be nums 1, first element, and dp will be nums 1 and nums 2. In every case we will be just writing nums I plus 1, one house incremented. Okay, that we can like think how is it working, and it should work now. Yeah, it is working, so let's just see. Okay, we are 2 minutes over of the 40 minutes, but that's fine, because today we did all our questions 100%, so that counts. So yeah, we are good with it, and that was the first day of us with DP. We are struggling a bit, I guess, at about the concepts. I've done these things earlier also, but like I'm not exactly sure about the patterns we can count encounter in the future. Like in these kind of questions, there might be some different kind of pattern that we can encounter, and we're not sure of how those actually work. So I have to work on it in the background a little bit. I have to learn about it, I have to see videos of its patterns, that how do we approach the DP questions. So after that we can do them also, but we will not stop doing this. We will stop every day, even if we do one question, but we will do it. Okay, so yeah, that's it for today, guys. We'll meet tomorrow again with the day 17.